Good morning, everybody. We get started on time, being in Switzerland here. It's the last day of our meeting, so we may get a bit into a synthesis mode. And as you saw, the title of this session is quite broad, and it's trying to synthesize. We actually have two parts of this session, as you may have noticed, A in the morning and B in the afternoon. And indeed, we will synthesize across both sessions in the afternoon. So if you can, please come back in the afternoon. Just to give you a few ideas of where we're heading with this rather broad spectrum of presentations, we're looking at the multifunctionality of land use in order to meet the different sustainability demands, sustainability criteria, context-specific local ones, but also more global ones, across all the dimensions of sustainability, from economic, environmental, and social. And with that, we would like to find ways of reconciling the different demands on land as they are specified most prominently in the SDGs. For doing so, we would like to address in particular the interlinkages, the synergies, the co-benefits, but also trade-offs and negative externalities between these different targets. You may ask, what's the role of land system science in all this? Of course, it's about developing the targets and indicators and then come up with methods and tools for these cross-sectoral and cross-scale and also cross-regional analysis and the interlinkages between these. So elements of this land science are models, is remote sensing, scenario development, big data may come in, case studies, and other elements. And obviously, all this has to be done in dialogue with partners from different sectors of society to come up with transdisciplinary science generating actionable knowledge. And the morning session will start from and largely focus on the agriculture and food system and how it ties in with the SDGs and to some extent also with the planetary boundaries. And in the afternoon then we will bring together these elements of land use, SDGs and planetary boundaries. We have quite a dense schedule, so we would ask you to stick to time, and my co-moderator, Benjamin, will be very strict on time, and we get started right away. So please make sure that you observe the signs that you get. Then that would allow for 1 or 2 questions after each presentation, and if we're really fast, we may have a bit of time in the end for discussion. Let's see how disciplined the speakers are.
Yeah, good morning, everybody. I'm pleased to announce the first talk from Arnout van Soesbergen from UN Environment, WCMC, and King's College in London. Arnout, the floor is yours.
Thank you very much. Can you all hear me? So my name is Arnout van Soesbergen, and I'm presenting here also on behalf of my colleague Michalis Hadjikakou. But I have to say this work goes back quite a few years, and so we're building on other projects in which lots of other partners and organizations were involved as well. And so I'm going to talk today about trade-offs among SDGs using future scenarios. Specifically looking at East Africa, which is obviously quite broad. So we have done a study for a larger region, but I'm going to focus on my results only on Tanzania. So context. So land use and land management decisions really need to consider the balance between trade-offs, and they need to capitalize on potential synergies and trade-offs between different SDGs. But they also need to deal with a very uncertain future. We have climate change, we have all sorts of socio-economic changes, etc. And so it's very difficult to make those decisions. And so drivers and trade-offs and synergies amongst SDGs, they vary through time, but they also vary in space. And so scenarios can help us. They can help us to consider what future land use may look like, but it can also help us to understand drivers and context for policy. And so we're doing a spatially explicit analysis that can help us to identify hotspots of change, looking at where impact potentially may happen across a range of scenarios. And we also do that to look at where are the spatial trade-offs. And so it can help us then to prioritize areas for action. Where do we need to focus our attention? Again, coming back to this, the sort of policy around land use and land management decisions. How can the scenario work inform that? And so the approach that we've taken is to start with socio-economic scenarios. These scenarios were developed for a larger region in East Africa quite a few years ago now. If you were in the scenario session 2 days ago, you will have seen more about those specific scenarios. They then were semi-quantified and fully quantified in a macroeconomic model, impact, developed by IFPRI. And that then tells us what the sort of demands are under the different scenarios, what the potential yield changes are, how that then affects production. And so essentially that speaks to SDG 2. This is about population changes under scenarios. What is the demand for food, and can we reach that demand within countries? But then that doesn't give us any sense of where impacts may happen. And so we need to spatialize that. We need to look in the landscape where are changes likely to happen. And so that was then fed into a land use change model. That was the land shift model developed by Kassel University, combined also with scenarios of conservation. So we looked at protected areas, we looked at key biodiversity areas as areas of future protection possibly, and so it also allowed us to look at different options for conservation and conservation policy. And then finally, those modeled land use changes were fed into a biodiversity and ecosystem services models to look at specific elements of SDGs. And I say elements because we're only looking at specific targets under SDGs. And we did that using a hydrological model called Water World and an ecosystem services model called Costing Nature. So very quickly, the socio-economic scenarios that were developed were the typical scenarios along the two axes of uncertainty. So we have a quite positive scenario called Industrious Ants, which has regional integration and a proactive governance. And then a quite negative scenario, Sleeping Lions, where we have fragmentation and we have a reactive governance, and then we have two in-between scenarios. And these were, as I said, developed by the CCAF's program, Climate Change, Agriculture and Food Security. And they were done for a number of regions, but as I said, I'm going to focus on Tanzania. So if you look at some of the specific drivers under those scenarios, we look at population change. So this is the projected population change under the 4 scenarios for Tanzania. We can see that by 2050, we'll see a more than doubling of the population compared to 2005. And the most positive scenario, the population is the lowest. In the more negative scenario, the Sleeping Lions, it goes up to 120 million. The most recent UN report on population projections actually projects a population of 138 million for 2050. So even our most negative scenario is actually already better than what is currently happening. If we look at specific commodities, so different scenarios have very different trajectories, of course, for crop production. We also had a drought event modeled in around 2020. But also, this is the maize production, this is a staple crop. If we look at the recent production, you can see there's a lot of variability, and that sort of interannual variability is almost larger than the uncertainty between the scenarios. So this is just to show some of the uncertainty in the drivers behind it. If we look at the changes in consumption in terms of meat, we see a nearly doubling of beef production for Tanzania, but less so for pork. So we see a shift in people's preferences. This is results for the more optimistic scenario, which means people are more affluent, have more money to spend, and therefore we see a change in diets. And obviously all of this has impacts on the land use. So this is the modeled change in land use. So on the left we have cropland, on the right we have pasturelands, and very quickly, this is between the baseline and 2050 for the most optimistic scenario. Very quickly you can see that we have a lot more pastureland, conversion to pastureland, than we have conversion to cropland. About 38,000 square kilometers cropland, 128,000 pasture. And obviously that land is conversion from natural land, and so we see a lot of conversion from forest land. So this is the loss of forest. Obviously you see the same spatial pattern as where the croplands and pasture lands appear, and this is the totals for the whole country. And again, we can see we have a lot more demand for pasture land than croplands. And so using those model changes, those spatial changes, we can look at what's happening to biodiversity under this scenario. So this is speaking to SDG 15, which is on biodiversity and ecosystem services. So we modeled how do these changes in the landscape, or this forest loss in particular, affect biodiversity. And we see high losses in areas that are already high in biodiversity, not surprisingly, but obviously areas that are affected by land use change. So this is areas around Ngorongoro, but also in the Eastern Arc Mountains, we see quite a lot of forest loss. So if we look at ecosystem services, this is a model that looks at a whole range of ecosystem services. We see a decrease, so this is combining those different ecosystem services. Again, the spatial pattern follows that of the land conversion, but we do see that cropland changes have a much bigger impact, or conversion to cropland, than pasture. SDG 6, so the clean water provision. So this is a model that looks at water quality. And water quality is obviously affected by land use as well. So this takes into account the conversions to croplands, to pasture lands, and what that might mean in terms of pollution of water. And so this is the percentage potential pollution, and so that increases under those changes. SDG 13, so this is about climate action. We see an increase in exposure to natural hazards. Exposure to natural hazards in this model is a function of hazard potential, which depends on population, which obviously increases as well, relative infrastructure, agriculture, and GDP. And so, again, because we have a larger area of agriculture, we are more exposed, and therefore there's an increase in this exposure to natural hazards. So if we bring that all together then, and this is also bringing in some of the other scenarios that I haven't shown you yet. So on the left here, this is SDG 2, so this is the area expansion of croplands and pasture lands that are required for the production of food. This is the scenario that I've shown you, which leaves protected areas intact. If we remove protected areas, i.e. we allow encroachment within protected areas as well, there's a lot more land conversion happening. And on the right here is the more negative scenario, scenario 4, in which case we also see a higher demand on land. And this is mostly because this is in this negative scenario, it's assumed that yield doesn't increase as much, and therefore, and obviously population is growing more as well. And so we need more land to produce enough foods for the whole country. And so the other, yeah, I'm nearly done. The other graphs here show the other SDGs, so SDG 13, climate action, we see all negative, sort of related to the changes in SDG 2, SDG 6 and SDG 15 on ecosystem services. And so, again, the trade-offs are greater in a scenario, this scenario, where we have no protection of land. Right, so just to wrap up then, under these scenarios, meeting SDG 2, i.e. food security, is not possible without agricultural expansion, but this expansion is largely due to an increased demand for meat. And that's mainly driven by the population increases. That's the main driver that trumps everything else. We need to produce enough food for the growing population. But that obviously has negative effects. So we have a loss of forest that leads to a reduction in water quality, loss of biodiversity, greater exposure to natural hazards. And spatially, not surprisingly, most of these impacts are where the changes in the landscape are projected, but no protection leads to large areas under land use change, but also greater impacts. And then finally, this sort of work, this sort of spatial work, this sort of using scenarios is a very useful tool to better understand these trade-offs, but also to look at where they might impact in the landscape. And so that can help us then to zoom in on smaller scales. And I'm going to leave it there. Sorry, just over time.
Thank you very much, Arnout, for this timekeeping. Very well done, and especially for this nice presentation. So we have time for 2 questions, please.
This one.
Hello, that was a good talk, thank you. I missed the very start of it, but it was good to see your actual quantification of the interactions rather than kind of a hypothetical one, which is really good. Man, cows really hurting the planet, huh? I mean, that's a message we're getting from a lot of the talks here, I think. And one of the things I think might help is, I don't know whether you're aware of this, people are growing beef protein from yeast now. It's vegan meat, and there's stores that are selling this now as well. Those technologies never seem to be factored into these future scenarios. I mean, the world changes so rapidly. I'm sure it's very difficult to keep in touch with, all the developments. But maybe maybe the prognosis from your analysis is a little bit more dire than it really might be.
Yeah, I think it's a good point. I did see some people sort of, not Rutger as well, when you mentioned that these things are not always part of the scenarios. I think scenarios are being developed, particularly now in more recent years, I guess, where those things are taken into account. And I sort of would agree with you that this is probably fairly dire. I mean, obviously we do take into account livestock densities, etc., etc. And dietary changes are taken into account, and we could also take into account things like, shifting diets away from meat, etc., which would have quite a big impact. But I guess it's more to do with the sensitivity of it. I think, we need so much land for rearing cattle that even sort of small changes have very big impacts. And so I think that's probably something to really be careful with when taking into account into scenarios, because it's up to 2050. It's really not that far into the future, and so these technologies for sure will make big changes, but we also have to be careful and think about the timeline of when these things can happen.
Thanks. And a quick question.
Yes, James. Yes.
To run the model using that variability around the mean and do it multiple times so you get some error bars on your...
So this is, I'm not the expert on this because this is part of the impact modeling. So what they would do is look at the recent production going back 10, 15 years. But yeah, they would just take, the mean throughout those years. And I don't know, it probably requires running the model several times to get that variability out of it. And so it's a good question, and we should probably discuss that with those modelers as well and see how they deal with that variability. For me, it was just to show that the uncertainty in the scenarios.
So thank you very much. So we go to the next presenter. It's Heera Lee from the Karlsruhe Institute of Technology in Germany.
Okay.
Thank you very much.
Okay, thank you. I'm Heera Lee from KIT in Garmisch in Germany, and I'm moving forward to the climate discussion, implementing the land-based mitigation to achieve the Paris Agreement in Europe and requires food system transformation. So I'm glad to follow up the discussion about the food system and dietary changes in this discussion. And as you all know about this climate Paris Agreement in 2015, this is to limit average global temperature increase to between 1.5 and 2 degrees, and it is agreed by about 200 signatories to UNFCCC. If we look at these trajectories of the Earth system in Anthropocene, and this 2 degrees is the range of destabilize the Earth, if we go beyond that, it's on the way to the hot Earth. So it is really important to keep this target in mind. But where are we now? We are in 2016, we are already above the 1 degree, which means we only have 1.5 and 2 degree according to the Paris target. And without any significant reduction effort, the global temperature will likely to reach about 5 degrees above pre-industrial temperature. So what do we have to do now? So this is the global carbon cycle. And in my presentation, we will look at the land-based mitigation in that session. Historically, the land-based change, land use change contributed about 30% of cultivated cumulative emissions between 1870 and 2016. It occurred mainly through a transition from a large carbon sink forest to the crop areas. For example, the forest area is a net sink, and peatland as well is the largest natural terrestrial carbon store, but also grassland can be dependent on a management also, but the cropland is both a sink and source, but depending on the management again. So in my presentation, I will focus on how we increase this forest area as a carbon sink, how we can sort of minimize the cropland area in Europe to sort of secure more land for the forest area. For that, we look at the food system, both supply and the demand side. As a supply side, we look at the different climate scenarios, but here we'll focus on the RCP 2.6 to meet this target. And the management issue would be the intensification versus extensification. But also trade plays an important role because we outsource the problem outside Europe. So we consider that issue in the supply side, whereas the demand side is the dietary preference, whether people prefer meat or beef or non-ruminant meat, or also different types of crops, such as bioenergy crops. What should we change now? So again, from the demand side, the eating habit. So less meat consumption, so both ruminant and non-ruminant meat consumption decreased, whether they change the meat preferences. In Africa, they tend to choose more beef, but in my scenario, we say change the preference from ruminant to non-ruminant, so less beef and more chicken or pork. And technological change would be more intensification, so yield improvement, more yield per unit area and less agricultural land needed to produce the same amount of food. And also irrigation efficiency improvement that increase the amount of food produced per unit of water. From the crop side, we also have some more bioenergy crop, is not much. And trade, important to mention that we keep it as a fixed today's level to avoid displacement of food production outside of Europe. To test this experiment, we use this integrated assessment platform, IAP, and this is cross-sector meta modeling from the Impressions project, from urban to biodiversity models. And again, for that we use the climate scenario, and the spatial resolution is about 16 kilometers in Europe, and a land use allocation was done based on profitability of the land and water availability and also soil condition. So again, we consider both supply and the demand side of this modeling to allocate the different land use across Europe. Based on this, that we had about 300 stylized scenarios, and we used 3 different climate models, end up with about 1,000 model runs. And then we look at whether these runs produce enough forest area and also enough food for the Europe. So first we look at the different dietary preference versus intensification. And about 900 or 1,000 runs, we only have 30% of the runs met both the food security and afforestation target. Food security means like at least they produce 2,800 calorific intake, which is global average. And as you can see here, most of the runs belong to this less meat or no meat group, so that means we need to reduce dramatic amount of meat to meet this forest areas target. And average yield improvement also about 15%, so it's not only the demand side, but at the same time we need the supply or more technological development. But the trade-off between this intensification and the dietary preference was if we produce or if we consume more meat or if we keep as today, then we need to intensify more, so at least 30%. So it's double compared to the less meat scenarios. And the level of food production was also different among these different scenarios. So I will show you in the next slide. So this is the forest expansion versus the calorific intake. So this is the average, global average, and this is the European average. And this different symbol, like the size of the symbol means the yield improvement, so from 15 to 75, so large means the more intensification, and different color refers to the different dietary groups. So darker here is more no meat to no change. So here is obviously if we intensify more, there are more land to forest area. So here is more intensified land. But interestingly, if we eat less meat or no meat, then actually more calorie is available in European land because then we have more land to provide our plant-based crops. So if we change from beef to chicken, that actually provide the least amount of calorie because then we need the land for both fodder crop and food crops. So that was the conflict between how much we want to produce and what kind of food we want to consume. And of course, this lead to a land use transition. And because we only consider the successful one, which means we have enough food and enough forest area, it requires a reduction in arable land, also dairy and grassland area. So average land cover transition between 2010 and 2015 in successful runs. And intensive arable land area can go to the forest if we change the drastic amount of meat and also about 15% of the intensification in average. But I also want to mention the average yield gap in Europe for cereal crop is about 40%. So there could be some potential in Europe, but not everywhere. Could be some chance in Eastern Europe. But again, drastic reduction in grassland because in our scenario, reduce the amount of meat, especially the beef. So it leads to about from 12% to about 4%, but it will also change the rural economy, socio-economic system, ecological system, and agricultural rooms. So people or farmers belong to this grassland will have some different socio-ecological conditions. The annual average meat consumption in Europe still almost double than the global average, so we can think of how we can adapt to this meat reduction in Europe. Of course, it varies spatially. So red is reduced, and blue is more increased. This is intensive arable dairy and forest area. So this blue, so Polish or this Eastern Europe has more intensive arable land area, whereas this whole western side would experience the decrease in this intensive arable land area, and the intensive dairy is overall decreased over the Europe. And if we then intensify this area, then it will also decrease this forest area. So again, the trade-off between the forest land area and the cropland area. The last slide with the conclusion. So I start with this. I start the study with those three questions: how can we, Europe, make a proportional contribution to the 1.5 degree target by increasing the forest area? And can we do while producing enough food without increasing any food import? And what are the consequences for land cover changes? So for that, we need to increase the considerable amount of forest land area, and both the supply side, I mean the intensification or technological development, at the same time the demand side with different types of meat or crop consumption would be necessary for this transformation. And shifting to diet with less or no meat consumption is necessary, but I can imagine it's challenging. But spatial distribution varies from more production in Eastern Europe, but changes in land cover not only affect the food production, but also related stakeholders, the farmers. So there are people living there who will be also heavily affected by these changes. With that, I'd like to thank you for this attention and the left time.
Thanks, Heera, for sharing your interesting results of a complex integrated assessment. Again, well done. Timekeeping was excellent again. 2 questions can be fit once.
Thank you very much. Very nice presentation. One of the the option you choose is import.
Yeah.
So less production in Europe, and then that will be substituted by import from other regions. So we are living in the same world. So that means Europe will be green, but others will be affected. And the net result will be still going to 2-3 degrees. So how are you going to address that issue?
So I can go back to the slide maybe that oops, yeah, I just, this one. No, in our study actually we didn't increase input, so we really we took consider of this aspect, so we don't want to improve or increase any input, so we keep as a 2 days level, so we don't want to transfer any like a problem outside. I don't know if your question was related with this aspect or.
Yeah, it's something like that, but even today's level of import
Okay.
in Europe
Mm-hmm.
from other regions actually affecting the other regions' biodiversity and the whole climate system.
That's right.
System.
Mm-hmm.
So I think we need to see the whole balance, global balance, and it would be nice to consider.
That's right.
The implications of that.
Thank you. And so today's level we consider in our model is 20% of food is produced from elsewhere. And we also experiment a bit with complete reduction of this input. But of course, then we really have more chance of growing forests. That's really correct. So we can, I think we will consider also this like minus, like negative input as well in our model. Thank you. Yep.
It's a really interesting study. Thank you. Was wondering how did you downscale? How did you attribute? How did you? You might have mentioned it or didn't have time to go into detail. But how did you downscale the 1.5 degree target globally to Europe and specifically to the land use sector? There's like quite a few steps going on there, getting from that global level into that very specific.
Thank you. That was really difficult, as you. Oops. Can you imagine? Yeah, that's right. So that's why we consider 2 targets. First is the, sorry, I'm certainly not available. So first we check with the bond challenge forestation target, which is a global effort to bring 150 million hectares of degraded land into restoration by 2050 and 350 by 2030. And we calculate the proportional forest and area of Europe compared to the whole global, and how much we should take from this target in Europe. So then we downgrade it into European scale of forest and area target. Then we compare this with the emission reduction target from the previous literature, and then we compare whether that match with the, and then in our result it's pretty much similar. So that's why, yeah, we took this target and also reduction target. I don't know how I can go directly to this slide, but yeah, this one. So there was one reduction target based on one previous study, and then this afforestation target based on bond challenges that we calculate the proportion of the forest and area in Europe. Thank you.
Okay, thanks. So we come to the next presentation by Michalis Hadjikakou.
Michalis Hadjikakou.
Yes, almost. Thank you. Comes from Australia.
Is there a pointer? Or do we just use that? Here you go. Yeah. So I'll get started. Well, morning everyone. My name is Michalis Hadjikakou. I'm a research fellow at the Sustainability Research Lab based at Deakin University in Melbourne in Australia. And I've come a long way to present work that my group and I have been working on over the last year and a half, which is a meta-analysis on food system scenarios in the context of planetary boundaries. A lot of synergies with what's been spoken about in this session already, as you will see. Now, again, in this session and in this conference overall, we've seen time and time again how food systems, as in current modes of food production and consumption, are impacting the environment, and how we are on very potentially unsustainable trends if we don't change what we're currently doing. Now, within the last decade or so, the planetary boundaries concept has come in, and it's sort of introduced this new paradigm of absolute biophysical limits across a number of Earth system processes. And yes, it's coarse, yes, it's global, but it provides for the food system at least. It provides thresholds that allow us to assess food system scenarios and not just talk about whether something is better than something else, but actually compare it to an absolute target. Now, there's also been growing literature in the last 10, 15 years on food system scenarios, global food system scenarios, and associated environmental impacts. And there's been many big reports, as well as lots of individual studies using models, partial equilibrium, general equilibrium models. With recent studies, especially the Eat Lancet report, actually explicitly comparing scenario projections against planetary boundaries. However, we still think there's two very important gaps that remain in this area of research, which is one, that accounting for study and model bias. There's, as we've seen this morning in one of the keynote sessions, there's this huge heterogeneity between these models. And there's also, we need to be honest about the really large uncertainties in the boundary thresholds, as well as the choice, the indicators we choose to define them. So this is what we set out to do. We asked the question, how can we prevent the impact of food systems exceeding planetary boundaries in 2050, while controlling for the fact that we're using different models to project. We have uncertainty, large uncertainties in the boundaries, and there's so many interventions being considered. And I'm going to present sort of a very summarized version of our results in 3 levels of analysis. Starting really broadly, I want to explain how we systematically reviewed the literature using a PRISMA protocol, a standard meta-analytic protocol to identify studies. It's published since 2000. Then we extracted all the relevant data on the parameters or predictors, as well as the environmental impacts, and classified, really important this, we created 4 scenario typologies. So BAU scenarios that involve continuing business as usual, efficiency increase scenarios, demand change scenarios, and in the food context that mostly means reductions in meat consumption or pescatarian diets, etc. And then mixed interventions that encompass both. And in parallel, we also needed to downscale the planetary boundaries to agriculture, hence my previous question. This is a topic in itself. I'm not going to go into detail in it, but the important thing was that we needed to do this for different indicators and account for what other sectors might be needing. So if we're looking at the climate change, for example, we needed to account for what the energy sector might require in that pie. So hence, triangular distributions, the mode is the most probable outcome, and then really large sort of minimum and maximum range. Now, these are the actual results from the authors, plotted as is, without anything done to them. And important thing to note here is green means safe, yellow means zone of uncertainty, and red is unsafe. This is just cropland. I'm just focusing on land system change because I can't do everything. And we can clearly see that BAU is really 95% of scenarios are actually in the red. And when you start actually putting in some interventions, then they're doing better, but the uncertainty, the zone of uncertainty is really, really wide. Now, looking at so if we're looking at total agricultural area, then the picture is slightly different, and this is where the nuances coming. And then if we look at forest as our indicator, then again, the overarching theme here is that BAU is really, really not good enough, and even efficiency is really not good enough. So you need more than that. Now, second layer of analysis is where we're trying to remove the bias in individual studies introduced. And here we use a simulation approach and develop an effect size metric, where we're looking at, very simply, I'll just introduce the BAU acts as the counterfactual. So this is a meta-analysis. It's a bit like a placebo in medicine. So this is if you don't do anything. And simply, the effect size would tell us what the percentage reduction is in relation to the boundary and the BAU. And a simple example here is if we start with, say, 10 gigatons of carbon and go down to 5 after the intervention, and our boundary was 0, then we've achieved 100%. So it's 10 minus 5 over 5, so 100%. So but this, to account for bias, we bootstrapped the selection of studies at each iteration of our simulations, and we took a random boundary draw from the distribution, as well as looked at the sensitivity if we remove certain indicators that define each boundary, and also removed studies one by one and run it again. So I'm only going to, again, focus on, this is when you take the medians of each one of those simulations and plot them as histograms. Again, focusing on land system change, we see clearly here that the mixed interventions are the ones that can push us into a safer territory. But again, importantly, some nuance gets introduced here is the fact that cropland is, if we define our total land system boundary with cropland, then we're actually underestimating the difference that might be made if we are, instead of considering total area of forest. So cropland is a very strict indicator compared to the other ones, for example. So I don't have time to analyze this, but we can talk about it later. And last stage was to see what are these actual interventions, specific interventions that get us there. And this is done by looking at each study. This is just 7 studies as an example, and then looking at what interventions they've considered, say population control, yield gap closure, waste reduction, livestock feed efficiency, diet, trade, more trade, etc., less food competing feedstuffs, etc. And when we then run generalized linear mixed models, we use the indicator, 12 models, where we use each of the indicators as a dependent variable, and then predictors are our columns here, so that would be the different interventions. And then the studies used as a random intercept. So basically that controls for the fact that different studies have very different projections. And then we take the final answer, the final predicted value, and compare it to the probability distribution to get a probability of exceedance of the boundary. And we run all possible predictor intervention combinations, a simulation for each indicator. Now again, I'm just going to focus on one simple last. So what you can do is take this database and then inquire it in any way you want. And this is just, again, land system change, cropland, total area of forest, and we created scenarios of different diet and different yields. And you can see that individually, improving our diet, unless we go vegan, which is 0 animal calories, there's still 50% plus probability of exceeding the boundary. Now, if efficiency or yield gap closure alone, again, even high plus, which is 75 to 100% yield gap closure by 2050, more than 60% for cropland, 55% for forest, 50% for total area, is still a lot. Once you start combining them, then you can get to sort of 25%, again, 40 for forest. But the point is, you need this synergistic sort of change. But even then, it's quite a high probability of exceeding, and high plus is really, really, really high. So I guess the overarching theme was to do this meta-analysis, to figure out how to do it. So I think we feel that we've created an interesting approach here as well, and we'll be making available all the data for people to work with, either the raw data as well as the modeled data. And it's an interesting sort of principle which I think is very promising, to think about scenario outcomes in relation to targets whilst accounting for all the uncertainties. And that could be even done at a regional level. This is global. Remember, it's still quite coarse. But importantly, I think this is not just a penetrating glimpse into the obvious, which many meta-analyses are, and it's still valuable, but we have shown a lot of interesting nuances, as in the sensitivity of the boundary outcome to the indicator choice. And I haven't even looked at the greenhouse gas emissions ones, where we look at where you include land use or whether you include the food system upstream stuff. It changes everything. So I think the outlook is generally a little bit more pessimistic, as is this session seems to be in the pessimistic sort of realm, unfortunately. And we're going to need to throw everything at it. I think the point before about disruptive sort of changes alongside demand changes is a very valid one. Very few studies have started doing that. Over the last 2 years, there's a couple big ones that look at really disruptive interventions like artificial meat, etc. But the ones we reviewed, every single one of them was really looking at current technologies, etc. So thanks. Thanks for your attention.
Excellent, Michalis. So 2 questions. We have time for 2 questions. At least one, please. Mark.
Just on your last point, your last bullet point there, it's what I would expect to hear. But in the graphs you showed earlier, the ones where you had the green, red zones of danger, of exceedance, but the mixed category, yeah, those,
Yes.
didn't seem to perform much better than the supply or the demand side. A little bit, maybe. But it's still a long way from the green zone, isn't it?
Okay, so yeah, exactly. It's very, very far away. It's far away from the green zone. So bear in mind, these are the raw data. So this is not the meta-analytic model. So this is like the data as they come. And I guess the mixed are still conventional changes. They're not disruptive by any means. So I'm not sure I'm understanding the question, because this, I think we're agreeing with each other. As in,
well, if you just hold on that. So
Yeah.
if you look at look at the central graph, cropland and pasture. If you look at efficiency,
Yes.
it's about there, and
Yeah.
diet puts you down in the green. But then mixed, which I'm assuming is a combination of those,
Yes.
supply and demand side, actually pushes you back out again.
Right.
So
So
it sort of contradicts a little bit what your last statement was.
yeah, and
Just
this
trying
is
to
not the
understand.
modeled. This is not the modeled results. So this is just really what those individual. These studies, this N152 is not. It might be completely different studies to these and completely different studies to these. So that's the value of what we've done. Is we've actually, this is not necessarily. They might be considering completely different dietary and completely different efficiency measures. So I think, yes, it's a bit confusing. I agree, but you would expect it to be pushing it as is here. Perhaps maybe you don't have enough. These are quite low and they're considering very different things. Yeah.
A burning question somewhere? Then we proceed to the next presenter, please. Thanks, Michalis.
Thank you.
David Leclère. Yes, not such a long way like Michalis. He comes from the Yasa in Luxembourg, Austria.
Thank you. Good morning, everyone. I'm really happy to present you the work of a lot more people than just myself. So it's about 40 institutions and almost 60 co-authors. So a lot of people to thank for the work. I'm going to be talking about reversing terrestrial biodiversity declines due to habitat loss using some multimodal type of approach. The motivation of the work was the following. We all know that there is a decline in biodiversity and the business as usual is taking us towards further decline. And that's not very satisfying. In particular, once we start to realize that we have started to try to do something about it. And it's by any means not able to reach what would be something like the Convention on Biological Diversity Vision for 2050, which is the valued, conserved, restored, and wisely used biodiversity. And that's not necessarily the only component of the future we want. And if you start to add all the SDGs on top of the picture, it's getting quite complicated about what should we do next. And one of the ways that has been suggested as trying to decipher what could be the next action steps to get to the future we want is use model projections. And that's what is going to be the talk I'm going to present you today. That led basically to what has been called the Bending the Curve initiatives, which is basically grouping different land use and biodiversity modeling groups at the global scale. That started about a bit more than 2 years ago. And the idea was to start with a fast-track analysis on bending trends from habitat loss. And the idea was to evaluate whether we can bend the curve of biodiversity loss without jeopardizing too much of the other SDGs. And if yes, what can we robustly say about how to get there? And one of the new components that we worked on was first scenarios. It started mostly based on the SSP scenarios, so the scenario framework that have been developed by the IPCC scientific community. But we needed to add some new elements on top of it. So we started with the baseline assumption, which is SSP2, the middle of the road social business as usual assumption. Then we looked at certain types of interventions that were by group and to isolate the effect of specific types of intervention. So one group was the supply side efforts. So we were looking at yield increases and trade increases. And that's mostly based on variations of SSP combinations. We looked also at demand side effort. So basically reducing waste throughout the supply chain and also looking at diet shifts. And this component was a little bit more ambitious than the most ambitious SSP, SSP1. So it's a new assumption there, but it's just differing in terms of how far we go in terms of diet shift and how close in time we intend to close or to reduce the waste so that the food supply chain. And the last component was increased conservation efforts, and that's where we actually spend a lot of work on gathering new data and making new assumptions about how much we could increase the protected areas in the future, where exactly. And so we reached something like 40% of land covered by protected areas as compared to a little bit less than, so a bit more than 15 today. That being said, it's mostly in boreal zones that you get this huge areal increase. If you look outside of boreal zones, it's only 4% of land. So it's still within the reasonable range of assumptions about the evolution of future protected areas. And the other assumption that we took was to promote restoration wherever we could and assume that over time, progressively, there will be an increased focus everywhere on land in doing landscape level planning, so that slowly over time you start to move production where it's least harmful to biodiversity, and you start to do restoration where you have potential to do restoration and where you had productive activities before. So that's the basic components of the scenarios, and then we looked at scenarios that were looking at combined actions, so planning these different subcomponents together. And the other aspect of the work was to take these scenarios and evaluate them quantitatively in terms of land use outcome and biodiversity outcome. And I skipped the slide, but I'm going to just quickly talk about the type of land use modeling we did. So we used 4 of the global land use models that are commonly used within the IPCC community. So that's Globiome, MAGPIE, IMAGE, and the AIM model. And we tasked them to translate these scenarios into land use change maps at the half-degree resolution at every 10 years time step for each scenario. And this was then input into the 8 global biodiversity models that you have here and that look at different types of metrics. So population trends, the abundance of wildlife. You would have metrics looking at the extent of suitable habitats, for example with 2 models, but covering different taxonomic groups. You would have models that look at the intactness of ecosystems, Predix and Globio, and you would have also models looking at regional extinctions and global extinctions. And these were then evaluating the impact in terms of biodiversity of each of the scenario for each of the land use models. And so that led us to something like spatially explicit and temporally explicit maps of biodiversity indices that you could aggregate also to the global scale for 10 indices for land use models and for each scenario, 7 of them. I'm going to give you a few results out of this experiment. The first thing we looked at is what is really the ability of our model to talk about the business as usual scenario. And no surprise, we continue declining until the end of the last quarter of the 21st century. So the doom story is kind of in there. It's good. And that was only for an illustration for 2 metrics that look at the intactness of ecosystems. And you could see here the change through time relative to 2010 for the historical period. So only one source of data, which was image height. And then in the future for different models where you can start to see the spread across different land use models. You can look at different types of indices, and they would disagree, for example, in the extent of or in the amplitude of future losses to biodiversity. And it would be typically much more dramatic for wildlife density than it would be for global extinctions. And you could look at, for example, the differences between models in estimating global extinctions. And you can start to see a lot of actually uncertainties around modeling all of these processes. I'm not going to spend too much time on it, but we had quite some interesting outcome out of it. The other thing we looked at is what happened in the most ambitious scenario. What can we really achieve something that looks like a bending of the curve? And the answer is yes, with a lot of uncertainty as well. And so we were able to obtain bending the curve for the most ambitious scenarios that piles up all the interventions for 34 out of 38 combinations of models. But as you can see, for example, here, you would have a wide disagreement between some land use models for the same scenario. And I'm not going to spend time again there, but it's reflecting what has been said this morning, lots of uncertainties about how much pasture is there already today used, how much we can restore it. There is a lot of uncertainty in the translation of land classes between the land use models and the biodiversity models. I invite you to have a look at the paper that hopefully is going to come out not too far away from now. And the second part of the question we investigated was how to get there. And that's basically looking at how we can pile up interventions and how we can obtain bending. And to make it short, we focused on three aspects. The first one is if we assume that if we see that there is a bending, when does it occur in time? When then we start to go up again? And that's basically here for one model in 2040. It could be for another model and scenario and indicator in 2050 or 60. The second aspect we looked at is what is the share of the losses that are avoided as compared to the baseline scenario. So here, for example, you would have, let's say, 25% of losses in that indicator, so it's external suitable habitat in the worst scenario, in the baseline, but then you would avoid basically 75% of these damages in one of the scenarios and probably almost 100% of it in the IAP and go in the integrated portfolio of actions. And the last aspect we looked at is once you have started to go up again, how fast you go up, or what is the speed of restoration. The robust insights, to make it short, are that we absolutely need increased conservation efforts, and we looked at not only better managed protected areas, but also restoration and landscape level conservation planning, which is probably the most disruptive part of it. And that's the only way that you can advance really significantly the date at which you start to go up again. Without that, no chance. And in particular, the speed of recovery depends highly on how you go, or intensive you go on this front. And we need to be much more bold than what we do today. But this is not enough if we want to be to secure the bending by 2050. And it's only by additionally tackling the drivers of habitat loss, so combining, using combinations of diet shifts, reduced weight, waste, sustainable increases in trade and crop yields, that we can secure the bending by 2050. One of the main effects is that it suppresses or reduces the impact on the short term in 2 decades of what will happen to the ecosystems. And the other interesting aspect is that it also allows you to get on track with a lot of other SDGs, and in particular, it generates large synergies with health, so the diet shift, with GHG emissions, with water use, fertilizer application, and so on and so forth. So that not only allows you to reach earlier the target, but also make it more consistent with the SDG agenda. Now comes the times of a bit of humility. Lots of limits. I don't have time to spend to discuss them too much. So maybe I can go back to this slide later in the questions if you want. But the main conclusion is that reversing the trends of biodiversity might be feasible by 2050, but it will not happen without ambitious and integrated action, and that calls for really bringing the integrated strategies to a much higher role in the post-2020 scenario or frame for biodiversity. I think that echoes a lot of presentations from today also. And as an opening question, this still does not allow us to be on track for the Paris Agreement, and this is definitely one of the next steps we want to look at, with all the caveats that you have seen earlier this morning, from the ability of models to really talk about that in terms of land use outcomes. Thanks a lot.
Thanks, David. I pick up your point at the last slide. One question.
For example.
Rüdiger, please. Rüdiger, please.
So we we can have another one. Your first slide with this maze figure. What is the unit at the x-axis, y-axis? I couldn't find it even in the publication.
So it's the publication itself is rather conceptual with this figure, but proposes 3 indices, I think, that could be used, but would have different trajectories in time. So I think you have LPI index, so basically wildlife abundance. You have PII, which would be something to better quantify the end target that we'd like to get to. And so it's intactness of ecosystems. And the last one was the red list index, which would help you to really halt the extinctions on the short term. But the figure I showed is stylized, yes. But the paper discusses what types of indicators could be used to cover different parts of the problem. There's one up there.
We're running out of time, unfortunately, so there can be one question. Please, Mark, sorry.
So can I go? Okay, so I think in the previous slide to this, you proposed a series of measures of how can we reach this goal. And I'm very surprised that you put sustainable increases in trade, because I still really wonder how do we scientists still believe that we can avoid all this environmental degradation but still supporting economic growth, like infinitive economic growth? Like, I think if there is a kind of actor that can be more revolutionary about discussing this kind of thing and really questioning, is us. So, like, do you believe in this proposal that you're saying, like you're happy with the trends that are happening around the world, and this is still like encouraging, no? More than questioning and really, there is something that has to change. This is still business as usual. So what do you think about it?
So unfortunately, the models themselves were not enough detailed on the modeling of trade policies. But there is a great amount of work to be done there, and there is also a big opportunity to revise them completely, because the current trend that basically over the last 20 years of just liberalizing is not even accepted anymore by countries. So it's not even working as a discussion on the table. But what could be working would be to really combine that with a better effort to make conservations on the ground. And I think you have ways to, for example, you have a lot of improved capacities on monitoring where the products are coming from beyond the country boundaries to know whether some products are contributing to deforestation or not. And that's something that looks like a better future for trade to contribute in a sense. And there is still a potential for trade to act as a land sparing mechanism within the whole target. And that's basically the reason why we started to look at this scenario. But I agree that there is a lot of work to make it really beneficial for the target. So it should not be a business as usual trade. I agree with you.
I would like to push the discussion a bit into the lunch break related to this presentation, or to the afternoon session if you are really able. We will have time for a common discussion in the afternoon session today. I welcome the next presenter, Morel from Lund University in Sweden.
Thank you.
Thank you. So 2.5 years ago, I started a postdoc in Lund University, and the goal was to explore how European agricultural systems might be able to contribute or affect the implementation of the SDGs in the European Union. And we were particularly interested in drivers and outcomes of agricultural systems, and also the huge amounts of public spending that is invested through subsidies in European agriculture under the Common Agricultural Policy. And so we put together what I thought was this really neat research framework to tackle the problem, and we set up a meeting with some policymakers in Copenhagen. And the meeting did not go well. And this is why. So we were over here in research land, and they were over here in policy land. And we were seeing the same thing, agricultural systems and policies that guide agricultural systems, but from two totally different perspectives. And I think actually Escher was imagining the science policy society interface when he sketched this back in the 50s. So back to the drawing board, and we then wanted to know how agricultural land systems are perceived by research and policymakers in Europe as a starting point, so we could better align our research with that policy. And today I'll just talk about two research questions from this whole 2.5 years of work. The first one is, which agricultural land system variables are the focus of research and policy in Europe, and how do they diverge? And secondly, how do European land system research and the EU's common agricultural policy align with SDGs? And we focused on kind of larger scale land system research because we were interested in Europe-wide policies and agriculture. So firstly, we reviewed 69 empirical research papers focusing on drivers and outcomes only in Europe, only on agricultural land systems and at this larger scale, spanning 25 years, so from this change in just land use, land cover science, all the way through to sort of land system science where we are now. And then the policies we looked at were the global SDGs, of course, the European Union's SDG indicators, so they have a suite of 100 indicators that they use. The EU's Sustainable Development Strategy, which has now been superseded by the SDGs. The Common Agricultural Policy, we looked at the monitoring and evaluation indicators for this huge policy, and also the agri-environmental indicators that the European Environment Agency uses to implement environmental concerns into the CAP. And once we put together all these variables and indicators that we found in the research and policy, we categorized them into these environmental and social categories of agricultural systems, and also determined whether they were a driver, a management choice, or an outcome. We compared the perspectives, research to policy, and then we aligned the variables that we found in research as well as the indicators in the CAP with these 100 EU SDG indicators to see where we were hitting. So research really focused on drivers, and a lot of drivers that were not in any of these policies. So there's a lot of, in this European research, there's been a lot of effort invested into studying drivers that actually we were finding policymakers either are unaware of or not concerned about. And this really reflected the methodological paradigms that we were sitting in as land system scientists. So going to the number one tool in the toolbox, GIS, maps, remote sensing data, data from Eurostat on statistics, but also some field stuff like surveys and interviews, and sticking all these drivers into our statistical models with a bunch of drivers and one outcome or a few outcomes at best. But we also saw some of these simulation models, so like we've seen examples today in this session of, what happens when some of these policy and social drivers change, like meat consumption, for example. And in contrast to this research focus on drivers, policies are really focused on outcomes, and a lot of those outcomes were missing from the research that we reviewed. And so we thought maybe this has something to do with limited GIS and quantitative data on these particular outcomes. Maybe they're covered by fields other than land system research. Maybe it's not the place of land system research to be studying these things. But I feel that there are actually opportunities here for novel land system research, linking things like health and equality with land systems, because I think it's very important and we can play a great role in doing that. And so what we learned from this first question was that we need to think beyond methodological paradigms. So think beyond GIS, remote sensing, quantitative modelling, and expand the analysis in the social domain using participatory and mixed methods. And also co-design research with policymakers, practitioners, other actors, and considering these multiple different actors that are involved in achieving the SDGs. So looking at how well the research we reviewed aligned with SDG indicators. So what this shows is the outer ring indicates 6 indicators. So the EU uses 100 indicators, 6 in most SDGs, 5 in SDG 14 and 17. So the research we found really focused on these 2, actually. So it's a little bit different to this skyline that the organisers of the conference have put together, where number 2 comes out a lot. There was a focus on 15 and also economic aspects of agriculture in Europe. But then these ones were missing. So health, equality, and also, you know, this good governance, institutions, and the role of those in achieving the SDGs. In terms of the CAP itself, again, a focus on 15 and 8, but also the food SDG comes in as well in CAP monitoring indicators. And we see the same gaps here as we saw in this land system research. So health, again, gender equality, and no monitoring of governance of the CAP. I'll just spend a little bit of time on this slide, which is, it shows the monitoring and evaluation indicators that are used to monitor the spending under the different instruments of the CAP. And so the CAP is split into 2 pillars. The first pillar is direct support, so subsidies, market measures as well, and that constitutes about 75% of spending. It's a huge amount of money, like 30 or 40% of the EU's budget goes into this one policy. And the rural development, the second pillar, gets about 25% of that spending. And we see that the monitoring indicators for the CAP under Pillar 1, where most of the money is going, don't really align with any SDGs. They're much better in Pillar 2, but it's not getting the money. So in terms of roads to land system research and policy for the SDGs, which is what this session's about, largely, we feel that there's a need to expand research focus on European land systems in the SDG, and actually the lit review we did is now 2 years old, more than 2 years old, so we've seen a lot of examples coming out in the literature now that is addressing this, so that's good, thumbs up. And also I feel that land system researchers could add valuable scientific evidence to these policy debates, and the CAP is being reformed now for the next budget period, so why not participate in that as scientists so we can kind of connect better the research and the policy to achieve the SDGs. And then really quickly, just as a bit of promo for what I was meant to do in that 2.5 years of the postdoc, and ended up just completing it at the end because we spent so much time on this sort of aligning science and policy. We finally put together this database. It's got 128 environmental and social variables in it by NUTS2 regions, which are these administrative regions. I'm going to keep working on updating this, getting better data in there, and we're also working currently now on getting all the subsidies data so that we can lay that on top. And we open this up to everyone. So we're really keen for people to have a play around with this, think about some questions, send me an email if you want to collaborate, take a photo of these links because you can't remember them. Thank you.
Yeah, this was interesting seeing the link from Pillar 1 and 2 to the SDG targets. It's quite,
hopefully we get that
quite
published
well
soon.
illustrated. Yeah.
Yeah.
So Holger, you have a question, and then over there.
Yeah, thanks very much for pointing out this need to bridge between land system science and policy making, one coming more from the drivers, one more from the outcomes end, so to speak. What popped up here and throughout the conference is the large role that trade and externalization of effects plays, and Europe has a strong role in that through being very heavily involved in trade and also in net imports. Where would that come in the policy field? Can that be integrated, or can that be addressed in the CAP, or is that sitting somewhere else? It's not the core of your work, but do you have any opinion on that?
Yeah, really interesting question, and I think you're hitting the nail on the head. So that comes into partnerships for the goals. So SDG 17 is about partnerships, international partnerships, and the CAP is very much about defending EU markets and EU agriculture. And so, of course, trade is hugely important for that. There's some monitoring of agricultural imports and exports under the CAP, but it's a tiny piece. I think once we zoom out from Europe, then it becomes hugely important. I guess these models that we're seeing, where you can start to incorporate some of these trade effects into the integrated assessment modelling, then that's when we can start to go back to EU policy makers and be like, hey, look what happens when you make this decision about meat in the European Union. What does that mean for sub-Saharan Africa that's now getting forests wiped out or whatever? That's a really good point, Holger.
Really great research. Thanks for the presentation. Curious, the gray bar, the portion that is not mapped to the SDGs, did you all look into that to see how much could be potentially undermining the SDGs or kind of working at cross purposes?
Good question. No, we didn't. It's really about accounting. That huge grey area on Pillar 1 is really just about like the EU member states having to keep track of where they spent their money. So it's just to tick the box, yep, we accounted for that, this many farmers got paid, this many hectares were covered. And like, it's not really linked to any objective of the CAP or the SDGs. It's going to be pretty controversial. I think the policymakers won't like me, but whatever.
So you was very well in time. So we come to the last presentation, which is a flash talk of 3, let's say 4 minutes. Sanderine, welcome.
Yeah. All right. It looks like something completely different now. I'm studying the impact of food systems, and I do this for now 25 years. And 20 years ago, I would present the impact of meat, environmental impact of meat consumption. And you listened well, because in all your models, meat consumption is a serious something in future demands. So, great. So, now I'm on the tomato. And I hope in 10 years I will be on this conference too, and I hope then all the consumption of vegetables is already also in your models. So what we did is actually have a look what's happening on vegetables, because we have the impression that meat actually is the problem, but there's a complete diet change. So we changed from the staple food diet, so only grains and beans, into luxurious food, and that's meat, but that's also vegetables. So we had a look at the impact of tomato production systems. And it's the most traded vegetable at the moment, and the production is increasing extremely fast. And if we took Germany as our starting point, Germany is actually not producing tomatoes themselves. They consume tomatoes that are produced or in the Netherlands or in Spain. And they keep on eating more tomatoes. So this is what's happening in Germany, and the picture earlier on the tomatoes is actually a picture in a German shop, and it shows that it's Spanish tomatoes. So we had a look at, well, there's a German consumer. He can choose between the Spanish tomatoes and the Dutch, and what's actually the impact of this choice. So we looked at the systems, and actually the tomatoes in Germany are coming from intensive systems, so it's greenhouse systems in the Netherlands, heated with glass houses. This is very intensive. The same system is actually in Spain. That's shown it's huge. And what we did is comparing those two systems, what's actually environmental impact of those systems. And we compared it on energy, on water, on whatever. And what we found is that the Dutch system uses huge amounts of energy. And the amount of energy for a kilogram of tomatoes produced in the Netherlands is far larger than for meat. So if you change from a meat menu into a menu with tomatoes, then actually the environment is not happy. The same for the Spanish system. They don't need the energy because it's hot there, but they need an awful lot of water. And the amount of water is actually larger than if you would produce meat here. So, and finally, that's very interesting, the labor requirements were the same. In both systems, the same amount of hours of labor was needed. And actually, that's logical, because it's hand-picked. And people can do the same picking in the same amount of time. So that's what we figured out. And so what was happening actually, that's the labor in both systems were foreign people. And in the Dutch system, it were people from Poland. And in the Spanish system, it were people from Morocco. So what's actually happening if for the German consumer, if he buys a kilogram of tomatoes, if it comes from the Netherlands, then it's heavily on the energy demand. If it comes from Spain, it's heavily on the water. And it has rather large impacts on rural areas or in Morocco or in Poland, because there's where the money is going to. That's it. So in 10 years, please have the vegetables in your models. Thanks a lot.
Thank you.
In time, come on.
In time, of course. It's a challenge, right? It was a challenge. So, any questions? Arnout, please.
Did you look at the sustainability of the energy sources in the production? Because I know for the Dutch greenhouses, a lot of them are using excess energy or heat generated by big servers, for instance. So Google and Microsoft are building massive server parks right next to the greenhouses.
But it's still a very small share. So what I did, I used the average energy use in the Dutch system. So there are certainly systems that actually use the waste heat, but it's only the 10% that reach the newspapers.
Okay.
So should we more often use Google in order to get a better...
we need to.
Okay, thanks. Yeah. Okay.
Thank you very much. Did you want to say that the social benefit of the tomato growing is very high, since it moves money from more rich areas to less rich areas?
Well, the whole labor thing is rather complicated in vegetables, because what we see is that there's also studies from England, and what you see for whole Europe, that they are using foreign laborers to do the work, and it's the labor conditions are not that great. And if you go for vegetables grown in Kenya or whatever, there you see that there are proper jobs. So you could even think of putting all the vegetable growing into Africa, because there it's creating proper jobs, while over in Europe it's actually a kind of slavery type of thing.
So, thank you. I asked Holger to wrap up our session in 2 minutes or 3 minutes, and then we can have a common discussion to synthesize what we have learned, and this synthesization, and we will further discuss this then after lunch.
Yeah, indeed. I guess for the full synthesis, we'll need the afternoon. But what I would like to say is that with this starting question, how to meet the multiple demands on land sustainably, we would like to continue that discussion in various forms, maybe in the form of further workshops, a paper, a special issue, for which this morning session and the afternoon session can provide the nucleus. So I will give you a few observations that I made, but this is not complete. Of course, with 1.5 hours, this big question cannot be fully addressed. We invite your feedback, and the 5 minutes we have are not enough. We are fully aware. You can come to us at lunch break to trigger further discussions. You can come back in the afternoon, and as I said, we will continue beyond today with this theme, including also Patrick, who couldn't be here in the morning, but Patrick Hostert, who will be here in the afternoon on behalf of GLP. Maybe very quickly, what are we aiming at? What are the targets that we're looking for? And the three main ones that came through most of the presentations here, again, no surprise, are related to providing food, to providing climate protection, and to also protecting biodiversity and ecosystem. But obviously there are many other demands to land which couldn't be addressed comprehensively here. A few were briefly mentioned. The last that we just touched upon was labor, obviously, and livelihoods, which really is a big theme by itself, which we're not addressing adequately here. Some other planetary boundaries were briefly mentioned that need to be addressed. And of course, there are sub-targets in each of these. Biodiversity was opened up into Living Planet Index, into Biodiversity and Techness by David, and so on. But there's much more. There's a much richer set of targets, and then also trade-offs between these targets that we need to tackle. So that's on the targets. Then the second big theme here was on interventions, looking towards solutions, obviously, and the big two categories here coming mostly from food sector, where on the demand side, like changing diets, waste reduction, and on the supply side, in particular, increasing productivity. But other issues were mentioned, and again, too briefly to be addressed fully here. Trade seems to be an issue that plays a role. Land use and land playing itself, of course. Then there was a brief mentioning of disruptive solutions, whatever that may be, and new technologies maybe, but maybe also others in fields of social or institutional innovations. Again, that needs to be unpacked to have a more comprehensive picture. There was a brief mentioning of other economic models beyond growth. And then, last but not least, to go through policies and how they can be more effective in terms of making land use more sustainable. And the third block that I would briefly like to mention here is about what science can contribute in terms of methods and tools. There was a heavy focus here on modeling and on scenarios, but again, that's not the end of the story. Some other methods and tools were briefly mentioned, but they also need to be brought in more comprehensively, be it data analysis, be it remote sensing, policy analysis, of course, and then the big issue of co-production with those that are involved in the solutions. So that's a big brush, broad brush overview of the themes that we touched in the morning. A few others will be addressed in the afternoon. But again, even with 2 sessions of 2.5 or 3 hours, we cannot fully address that. So we invite anyone with an interest to start synthesizing around that theme, using the GLP community and beyond, to contact us. And of course, we invite you to come back in the afternoon. Last 2 minutes, we can, you moderate again the last 2 minutes that we have. If anyone wants to overdraw, I can go a few minutes longer, I suppose.
Thanks, Holger. Yeah, it was right. So 1 or 2 comments on this, 1 and 2.
More an observation as an outsider of this community is that I see a lot of self-editing, particularly around how difficult diet shift will be, but also replanting 700 million hectares of forest is also going to be very difficult. So as we're looking at these models, I think we shouldn't let some of the narrative that I think is heavily influenced by the meat industry and the amount of influence they have on our governments to also edit the solutions that we see looking forward. So I think we should stop adding that every time we talk about diet and really just open ourselves up to all the solutions. They're all going to be difficult.
And the other implicit point that you're making is there is another whole sector to be included in the solutions, which is the private sector. We cannot simply leave it at the point of saying, sorry, we don't talk to them.
Thank you very much. I think talking about SDG and even from the morning presentation and many of the presentations made here, it looks like there is a tendency to focus on the OECD countries and Europe, and less on the global south. So my appeal is to the land system scientists. I think we need to see how we can also address the global south in a better scientific way, and so that we have a very clear understanding of the whole land system issues globally, not only a specific area and a specific part of the continent.
Of course. And we all know why that is, why we're here in the middle of Europe and many other reasons that play into this. There's possibly several avenues. One of them may well be the SDSN network, which is having hubs all over the world and which is reaching out to the scientific community quite actively. But that's certainly not the only one. Thanks.
Yeah, I just wanted to touch on the interventions part, and especially trade. Now, in our meta-analysis, we wanted to sort of look at all these interventions that are less talked about, like, for example, increasing yields or reducing diet animal products in our diet. Those are sort of the main ones, and they seem to have the biggest influence on effect size. But trade is kind of traditionally seen as a bad thing, and in a way, what we're seeing is that across different indicators, especially ones like water, it can actually introduce a lot of efficiencies if you're producing in an efficient location and then shipping out to places that would have produced something much more inefficiently. So I think there's a lot of nuance around trade, and I do agree that sort of a business as usual approach to economic development and more openness in trade is problematic for many reasons in the food system, as in changing diets and towards more sort of processed foods and sort of producing other problems. But I think we need to think about trade as a force that could do good if used in the right way. That's just my point.
Yes, of course, and it's not only that we need to start thinking about this. There's quite a rich literature actually on looking at potentials for improving overall efficiencies through trade. But that obviously is that usually is quite top-down research, which really, and that's something, another strong point coming through in this conference, needs to be married with more contextual bottom-up research. So, yes.
I mean, trade is not only from the perspective of the European system, of course, but it can also be a key in addressing zero hunger in Africa. So while people often have limited access in Africa to markets, most often due to monetary constraints, but it can also be a proxy of getting higher renewable in the smallholder system. Yeah? So, and then they get a bit more money to cope with poorer harvests in the next season. Well, last question, please, and then.
It's not a question, but it's a comment about trading. If you look we're talking about the SDGs, and of course, this is poverty is number one, and think about how can we alleviate the poverty issues. Trade is very important, because if you look at the global food production and demand, they are okay, but there are still a lot of poor communities. That's because they don't have access. I think here we don't talk about access to the food rather than just the production. I think trade could be a very important and as a supply chain.